Hey everyone, my name is Nick Peoples, and I'm a really grateful ARC scholar and graduate student at UC Davis. So before coming to Davis, I completed my undergraduate degree at Duke University and my master's degree at Boston University. And I'm now a fifth-year PhD candidate in the Population Biology graduate group at UC Davis, where I study the diversification of fishes with Peter Wainwright. Outside of my work, I'm a really avid fly fisher and soccer player, and I really enjoy all of the wonderful outdoor recreation opportunities that Northern California has to offer. And so I'm really interested in evolutionary innovations. And so these are really important traits of an organism that provide a species with new functions. And my research uses a combination of phylogenetic comparative methods, high-speed videography, and functional morphology to understand how these innovations are changing the trajectory of evolution within the over 30,000 species of fishes. So one focus of my research is on fish teeth, and fish have a really incredible range of tooth shapes, including those that have multiple cusps, like the ones shown here. And these are similar to kind of the molars in mammals like that we have. And so these different shapes are really important for determining how a tooth functions when a fish is capturing or processing its prey. So for most fishes, when they're capturing prey, teeth aren't going to be playing that much of a role. And so in this case, you can see that this killifish, as it's feeding on this brine shrimp, the jaws are protruding forward, but the teeth are not actually really contacting that prey. So in contrast, for fishes that feed on a lot of benthic-associated prey or food resources that have to be removed, teeth play a really important role in how those food resources are actually collected. So now in this case, this is a damselfish feeding on a simulated food resource on a block. And you can see that as those jaws are contacting the surface, they're both scraping together. And those teeth are actually going to play a really large role in the removal of that food. So now when we film this fish feeding at a different angle from the front, we can get a better idea of how these teeth are functioning. And so now we can see that as the fish is contacting the substrate, the teeth are actually conforming. The whole row of teeth is bending and conforming to this surface. And as the jaws scrape together to close, the teeth are actually maintaining contact with this surface. Thank you all for listening to this short presentation of my work. And I'm really especially thankful to the supporters of the ARCS Foundation for allowing me to pursue these research opportunities. Thanks.